Okay, we started. Good evening, everyone. We will proceed with today's session, which is help session with assignment 2. Many of the two sections, people have advanced enormously with this assignment, but we still think there is, let's say, half of the people still are struggling. And moreover, if they want to get excellent submission, they need to go a little bit more than the minimum. So actually this session is to answer your question, if whatever you may have, and to give you some guidance how to do better in this assignment. Elena, the
Yes.
stage is yours.
Yeah. So I guess this is an agenda. There are going to be some quick reminders, and we're going to discuss this is probably, I'm not sure whether or not if it's in the classroom, but I'm going to show you a little bit about the Markdown for the Jupyter notebook, such as table of contents. Then few important key points about the parsing function, etc. And then the part 2 tips. Then there is a little bonus for those who are listening to recording or attending live. Then we have answers to ungraded exercises. All of you have been waiting for, right? So now I'm not sure how much to emphasize this, but I need to remind everybody not to enter credit card number because you cannot undo it. And who's going to be responsible for the cost? You, right? Now, I always say to stop the runtime environment before exiting, but good news are most of the time, somehow, something is going on. The hours were not counted. But don't count on this, but well, do not open any tickets with IBM unless you're told to. Then you all know, hopefully you all know the Salesforce procedure, right? Most of you have been doing a great job with providing detailed information such as steps to reproduce the issue, screenshots, right? But I'm reminding you because the thing is, if you don't specify the steps to reproduce an issue, you're gonna create another round of back and forth, right? I'll have to ask you for a screenshot, and then it's gonna take longer to help you, right? So then, before you start writing, when we start working with a notebook, you must upload your data first, okay? Do not delete object storage, please. It's gonna create a bigger mess than you can imagine, right? Now, by now, everybody should know which environment you're using. It's Spark 3, Python 3.7. Do not select other environments because first of all, the notebook, the Titanic notebook, it was not tested in any of those, right? Then we are using Python. We are not using R. We are not using Scholar, etc. Right? So make sure you use correct environment, right? Uh, now, I'm gonna show you a little bit about the Markdown cell syntax. So basically, if you open up the notebook, I may have to open up the notebook. So here it is. This is a project, and today, for the purpose of today's demo, I created a different notebook. It's not Titanic. It's not low birth weight, but this is the heart attack data. So what you could see in here, this is the heading, right? Well, first of all, you need to be in the edit mode, right? I'm gonna click on edit, and I'm gonna show you a little bit about the Markdown language. So what it is basically it's a non-code cell where you may specify the description, you specify the explanation of what your code is doing, you put some headings, and you put the table of contents, right? You're required to have a table of contents in your part 2 of the assignment, right? Part 1 code is given. Part 2 is your opportunity to write the code. But take a look, if I double click here, what is this? If you see a single hash, right, it's a level 1 heading. And a double hash, it's gonna be the level 2 heading, right? So when you edited the cell, right, you would run it to make it look the way it was before, right? So here, this is a table of contents. So the way it works is that, see this? Well, first of all, it's a bulleted table of contents. So I spelled it out for you. So hyphen is a circle bullet point, right? So that's a hyphen. Then a menu is just but a set of links, right? So as you see, this was in the Titanic notebook, it's like this, but in this example, do you see the stuff? It's bracketed, right? So it means that this is a link to another session of the document, and this is the anchor. See this? So somewhere down in my file, I have something like this, right? I have this anchor. So it's in here. See this? So it's gonna look up. See this? This is the link. This is the ID. ID, right? And this is what it is over here. Somewhere down, I have this load libraries, right? So this link is gonna take me to this heading here, okay? So I hope it makes sense how this works. And then for this is a table. So if you're familiar with HTML, this is a table opening tag, and then you've got the corresponding table closing tag at the bottom, right? A table consists of rows. Now this is a table row, and then you have the closing tag for table row. Then you've got the table data. It's a cell within inside the row. See this? So you've got the cell which lists. Let me show you. I'm gonna run this. So see if take a look at this. This is a table, right? So this table has what? 1, 2, 3, 4 cells, right? We have 4 cells, but here this big cell, it's a row span. See this? You can specify one cell to span several rows. Okay. So if you look at this code in here, you specify the width, right? Then you can specify the font and etc. So this is just regular HTML. And this is the link to the image. You specify the URL of an image, well, and etc. Right? See this? It's on here. Row span 17, right? That's what it is, row span. It means that the column spans across the column cell spans across several rows. Okay, so that's what it basically is. And you see an example in the Titanic data, and you're also gonna have this example here. Okay, let me see. I thought I saw the questions. No, I saw something. No, I did not. Okay, now so here I hope it makes sense, right? I'm showing you how to do that. And here, this is just, I spelled it out for you. This is how it's done in Titanic notebook. All right. Now, this is very important here. And I guess, Linesh, you might have an idea why I put this in bold, right? Well, because, well, this week we had a case when somebody, well, they took this line of code and they put something else instead of word label, right? Like see here, you can change person info, you can change this too, but this word has to be labeled. What is this? This is a line of code that comes right above the parser function, right? So in here, do not rename the word label because then, well, see label document, this is an object, right? And it takes 3 inputs. This third input, it has to be labeled exactly, because if you change that, you're gonna get an error. And trust me, sometimes it's hard to see where the error is, right? So what you will do is, well, this is how it is in the Titanic example, where you define the custom parsing function. And what it does is that you read the data from the CSV file, and the parser is gonna, well, then you're gonna loop through all rows in the CSV file, and you're going to parse one row at a time with an exception. You're going to skip the row that contains the column headers. So this is Titanic. And if you look at this example, this is a parser function using all variables. So here, this is a data set. In here, you have information on the patient ID, right? If patient is a male and a female, age, education, and etc. And this is a 10-year risk of coronary heart disease. So in this specific case, you have this parser function, but notice what I'm doing in here. As a start, very important, you want to list all your columns. In that data set, there are 17 columns. Well, look, in Python, we number starting, the list elements are numbers starting from 0, right? So if you programmed in R before, in R you start from 1, but in Python we start from 0. It may help you to list your columns like this, right? Because when you start defining the parsing function, I'll show you what I mean. So here, look, this is a label document. It takes 3 inputs. Please do not change the name of this label. It has to be like this, right? So I'm calling the parser function. I'm passing it. The parser function takes a line from the CSV file as an input, and it splits the line into the columns, right? It's delimited. So in this case, my target is at position number 16, right? Because this is the last column. I have 17 columns. The columns are numbered starting from 0. So this is position 16. And then I'm checking if it's greater than 0, then it's 1.0, right? Otherwise, it's 0.0. Remember, it has to be one decimal point, right? 0.0 or 1.0. Now here, this is the concatenation of all variables that I'm using as the predictor. At a moment, this is a function that's going to use, I'm going to use all of them as a predictor, okay? Now, here, this is an ID, and notice that in here, this is the first column, which is at position 0, that's what it's doing. So this is a function that will be called, and then somewhere further down in the code, I'll be calling that function because I have to. It's in here. See this over here. It's gonna loop through all rows in my data, and it's gonna call the parser function. But here, what I'm saying is that if the row contains this patient ID, it means it's a header. I want to exclude. I don't want my header to be counted as if it was a data, right? And then I'm showing the number of records. That's what it's doing in here, right? So let's go back, right? And then you just call in the function, or you just call in you're just running the method, right? You're using a pipeline. So now in here, in the Titanic example, you did a split 80% to 20%, right? Part of the data is used for train, another part of the data is used for test. But for this data, for that data, what was figured out is that well, I played around with it and I figured out that splitting it 70% and 30% gives better results because, well, you don't want the model to overfit to the data, right? So if you see the accuracy for the training set 95% and for the test set 60%, then there is a problem somewhere, right? So that was my solution. It made a big difference here. Okay. Now this data set is also the target variable is also imbalanced, but the data set size is bigger in comparison to your part 2 data set. This data set is larger. Okay. So now so part 2 tips. you want to make sure, please do not forget to add this line in first schema true, because if you don't add this line, you're gonna have a problem. First of all, instead of displaying the average age, what you're gonna do is you're gonna display the average ASCII value of the column. That's what some people did in a Spark tutorial. At least several people who I assisted, I saw that if you omit this line in first schema, true, then when you start working, computing your averages, you're gonna do the, you're gonna see that it's an average ASCII value. And then all of a sudden, how could your minimum value, minimum age, be higher than the maximum age, something like that, right? So you want to always check the results, right? So most of the code errors are in a parsing function. Guys, trust me, 99.9% of errors are caused by something in a parsing function, because you cannot just take the Titanic data and plug it in and say, hey, it's gonna work. No way. You have to modify the code for part 2 data. Well, to start from, you could start either from the blank notebook, or you could import the Titanic notebook, but when you import the notebook, it allows you to specify the name, right? You can just enter different name and work from that, but you have to be, you have to make sure that you edit the code and you also edit the comments, right? Everywhere where you mention Titanic, it has to be replaced with the data you're working on, right? You can, for instance, if you do the browser search for Titanic, it gives you all locations in the code that reference in Titanic data, right? So like, for example, let me show you what I mean by browser search. I can do Control F, right? And then if I type Titanic, oh, you see this? This is a problem, right? So see this? This is how you're gonna edit. It found the accuracy of the word Titanic, then you have to edit it, right? That's what you're gonna do for your for your part 2. You want to make sure that there is no Titanic mentioned, like it's in here. See this? I'll have to edit this sentence, okay? This is what you're gonna do. Make sure that the code is written for part 2 data, all the comments are updated, and etc. So you can do the search as I just showed you. Now, what else is here is, oh, yes, I'm gonna give you this example, and this example has a little bit of bonus. Well, look, we are here, we are doing this session, right? But the session should not repeat what's in the classroom. We need to add value to what's in the classroom, right? So I'm gonna add value by showing you some fancy plots in here. In this specific data set, all of my variables have numeric values, right? Oh, you want to go over part 1? Yes, that's what I'm doing, but I'm using different data set. I'm using a different data set to give you to explain you how part 1 is working. Because what you're giving Titanic, this is the homework, right? So I am doing this homework, but on a different data. Because look, if I give you the solution, everybody's gonna get an A. Then I would need to go to Salesforce and submit a ticket to add me to Professor Gorchova and Professor Azan's gradebook, right? So are we answering specific questions about the part 1? Definitely. But so see this is the in your part 2, your data also has all the variables have numeric values, right? So what I'm doing here, instead of doing a histogram for one column at a time, I define the function, and the function takes a data frame. It's gonna take the list of the columns in the data frame, right? And it's gonna take number of rows and number of columns, and then it's gonna build the histogram for each variable here. That's what I'm doing here. Okay, so you can do that. This is a piece of code, you can reuse it, but your number of variables is different. So you may need to adjust the number of rows and number of columns. But see this, if you want to add value to your submission, part 2, you can reuse this function. Sure, instead of doing one field at a time, go ahead and reuse it, no problem. Okay. Now, this is another example. This is a pair plot, but you need to import this package. You have to import the Seaborn package. Then there is a function called pair plot, and it takes pandas data frame as an input. And this is what it'll produce, but it takes a little bit time to run. Now, you are asked in your assignment, you're asked to discuss the relationships among the variables, right? Because the data for part 2 has numeric values, you can do this heat map. But again, you have to import the Seaborn package. You have to do what I'm doing in here. See this? You have to import this package, and then it should work. So you could build this. This is the heat map, right? And it will show the correlation among your columns, right? So for example, see this is the, if somebody is a male, right? And this is a heart rate. So basically the columns are listed here across, right? Each row is a column and each column, right, is a column in your data. And then the intersection is a correlation. Remember, correlation values are between 1 and -1, right? So now, in this case, in the case of this data, if I was actually doing it for grading, I would probably check which columns have a high correlation because, well, you want to make sure that your predictors are independent from each other. For instance, in this case, I have a field, I have a column that checks if person is a smoker, and another field checks the number of cigarettes that the person smokes per day. Probably I want to pick one of these, right? Perhaps I want to just track if person is a smoker or not. Well, how do I know which one to keep? Probably I want to look at the distribution of cigarettes per day column, right? Then, well, I could probably see if it's skewed, right? And then I would see probably it may make sense just keep if somebody is a smoker or not. We don't care how many cigarettes per day, and etc. I'm just giving an example how you can decide what to keep. Okay. Now, but specifically, okay. Now this is a question. When you were going through instructions for part 1 of the assignment, it may seem like notebook would already contain. Okay. Now let me clarify. There are 2 notebooks for Titanic data. There is a notebook. If you look at the assignment 2 folder, in the assignment 2 folder, you are given a notebook on logistic regression, right? Let me close what we don't need. So if you go in a classroom, right, it will give you, in the classroom, you will see assignment 2 folder, and in assignment 2 folder, you have a notebook for logistic regression for Titanic data, right? So this is what you need to run and submit for the grade. At the same time, if you go to week 5 and 6 content, there is a notebook with naive Bayes method implementation. So basically, if you think you can, it could probably, well, part of the assignment, it asks you about the alternative methods that could be run on your data, right? Alternative methods. You could discuss it, right? You could easily discuss, I think that naive Bayes or decision tree method could be suitable for this problem because the other. Alternatively, you could take the notebook that I gave you, right? The given notebook with naive Bayes implementation. You could run it and then in your paper, compare the results. You actually compare. That's an option, right? Why not? And then I had students who would go beyond on part two, and they would implement the method logistic regression and naive Bayes. Well, I mean, if you are done with assignment early, I would say go for it. I mean, because, well, you're taking the class to learn, right? Let's say it this way. It's not just getting the easy A, not getting the ticket punched, if you will, right? So to learn more, you want to take advantage of what's given. Plus, now I know that for some reason it does not always count the hours. So hours is not a concern, right? If you want to learn more, or if you want to save the copy of that notebook and then run at your leisure later on, after class is over, you have that option. I hope I answered the question. Did I? Please let me know if the question is answered. Okay, will this video be uploaded? Yes, of course. Yes, of course. This is a part of the customer service. So all of this is recorded, will be uploaded, and also I'm gonna give you a copy of this notebook, right? And I'm also gonna give you the slides. But this is a little bit more advanced example because, well, the sessions that we have to add value to what's in the classroom. We cannot repeat what's in the classroom, right? All right. So this is basically, there are more advanced visualizations. That's the main difference in here, okay? Because, well, see here, so this is more for you. I mean, I realized that, well, please also add the slides. Absolutely. Oh, from the last Zoom session, Gabrielle, I saw it. Oh, Grace, Gabrielle. Okay. Well, I saw the last Zoom session slides were in the course announcement. You're gonna look into it because if you look at the announcement, there was a link to the session recording, and there are also slides attached. You're in session 9041, right? Well, we'll need to check afterwards. But Grace, I'm glad that you were able to attend because you will see what's coming in the later part of presentation. I'm giving you credit in the later part of the tonight's presentation. All right, so here it is, right? Now, there is a part that all of you could not wait for, right? There is a part of this presentation. Well, first of all, before we do that, before we go to the part that you have been waiting for. Now, first of all, same as the notebook, output as PDF. This was a common question. So let me go ahead and show you that. So, yes, I'm gonna show you how to save the notebook. Okay. Oh, you were accessing. Okay, no problem. No problem. Yes, yes, yes. The notebooks are closely similar, mostly similar, but the difference is the method that it is. Yes. So you have both, right? Why not? I mean, you're taking a class to learn. Let's assume that you're taking a class to learn, not just to get the ticket punched, right? Now, take a look at this. This is how you do this. You're gonna do file. You're gonna do download this HTML, right? Depending on the browser. So see this file is here, right? It's gonna be installed wherever your downloads are. I'm gonna open the file, right? So now I have an option. I can print this. So to print this, I can just go print, right? And when I do that, there is an option to save this file as PDF, right? I'll save it as PDF. Well, it takes a little bit of time because this file is huge. I have a lot of examples in here. So see this, right? And then I will just go in and I'll put this, right? Save. And now I can name the file, okay? I can name the file in here, whatever I want to save. Okay, I'm gonna hit cancel, okay? So this is what you do for the submission. Now this is what you do for the submission, for the assignment submission. Now, and I'm gonna assume that everybody knows how to count until 3. You should have 3 files in the assignment folder. The output from the Titanic, output from the low birth weight data, and also the write-up. If you did the naive Bayes and if you want to submit, you're more than welcome to. Okay, you're more than welcome to do that. All right. Now, most of you have been anxious to see the solutions. This is ungraded exercises. So now ungraded exercise 1 builds on top of, it builds on last graded exercise. So here you're asked to list one line. See this, the first column is accounting, well, department. You list department, you list salary and the number of employees, right? In column 1 with the salary in column 2. Okay? So you have two grouping columns, department and salary. Both grouping columns in a select clause must appear in a group by clause. So this is what you do. Now, sorting is case sensitive, so that's why you want to convert the department to the uppercase, right? Because otherwise it would put uppercase letters ahead of the lowercase letters. It could put IT ahead of accounting, right? So this is something to just keep in mind. Now the second ungraded exercise is built on top of the first one, right? It's another column. You add in another column here, and 3 columns in the group by, right? So far so good. Now exercise 3 has multiple solutions, and I'm gonna give credit to some students here. So this solution was mine. So what you're doing in here, you know that the value of attrition, right? If employee left, then it's 1. If employee stayed, then it's 0, right? So if I take a sum of attrition, it's gonna give me how many people left, right? Count gives me the total number of people, and then I take a difference. I take the total number of people minus number of people who left. It's gonna give me the number of people who stayed. Remember that you can have more than one aggregate function in a select clause, right? Count star, this will return the number of rows, right? So this, but see here, this is grouped by department, right? So total number of employees in department. Here, we can assume that the attrition is always populated, because if we had some rows where attrition was null, then the number of people who left, right, plus the number of people who stayed would not add up to this number total. Because the count star, it will ignore the missing values. So just keep that in mind. In this specific example, we don't have missing values in the attrition column, right? So we're good. Now this was my solution. This is a common solution. This is a common solution. Oops. So, oops, on the bottom of the slide, this is a common solution. So what some of you did is this. You put a sum, but you put a case statement. For instance, if attrition is 0, then 1 else 0. So you can use the you can use the case statement. So what people did, some of you use the case statement over here, which is fine too, but you have some columns backwards here. You display the number of retained, then the number left. It does not matter, but the point here is that you could use this case statement in here, okay? So if attrition is 0, then the person is retained, see this? So if the value is 0, then 1, you take in the sum, see? And here the other way around. So this was the dominant solution, which is great. This is correct, excellent job. So mainly the expected solution was this or the one at the top, but we have some people in session 9041 who made an alternative approach that I have not even thought of before, and I want to recognize their names in here. So the first person is Ben. So what Ben did was he used inner query. He's using inner query to pull the number of retained people, the number of people who left in here, and then he is doing a join, right? So he's doing the total, right? Count stars gives him the total. And then in here, oh, see this? This is what he's doing. He's doing a join. See this? So here you have an outer table, which is the EA. So this is the outer table. And then in here, this is a subquery, which is an inner table. Some of you try to do the subqueries, but you have to have a way to join your subqueries to the main query. And the reason he's doing the left join, which is correct, because you could have departments where you have people, but there could be a department where all people stayed, nobody left, right? You still want to list the department. Then if you have a department where everybody left, nobody stayed, you also want to include the department. So this is why you have to have an outer join or left join, right? The joins are not required, but your schoolmate Ben, he made it work with a join. So I have to recognize his name here. Now, so I have to do this. All right. Oh, what is this? Oh, okay, you responded, Elon, I see that response. Okay, no more. Now, here, as promised, Grace, I'm gonna give you the credit because this is your solution. What you did was here, you created a view, right? You created a view and then your query is selecting from a view. This is an out-of-the-box approach, which was unexpected and it's correct. Excellent. So we like to see creative solutions in here, okay? Okay, yes, we'll go over creating the data frame. But you need to show you need to be the specific question, okay? We'll go over it, but let's finish this now. So this is the Grace, it's her solution, excellent. And another person, this is a Sarah's solution. So what she's doing in here, she's using a count. So if the person retained, right, then one, otherwise null. Well, because count function ignores nulls, so that's why it's correct. See, this is correct because it will ignore the null values. This is correct. Yeah. Using a count is correct too. So I'm just showing you different. Oh, no worries, no worries, no worries, no worries, no problems. No, but I mean, no, nobody is a problem. Everybody is excellent. All students are excellent in this program, okay? Excellent in their own way. So this is Sarah's solution. See, I like to recognize people. All right, now let's go back to the question. What explicit are you referring to converting the RDD to data frame? Could you please elaborate? Because when we upload the data, we are creating both data frame and RDD, right? So could you please elaborate? What are you referring to by where exactly? I can look at the Titanic data, but you need to tell me exactly where and what are we looking at? Because I'm trying to figure out, this is just a generic question. Maybe Linesh can figure out. Ah, the lambda function? Okay, okay. Lambda function? Oh, like the one on, like the one, let me see.
The
Yes.
processing, creating data frame from RDD or maybe
Oh,
the
it's not a
process
data frame.
function.
It's not creating, it does not create a data frame. Well, hold on. Where? Which lambda function? Can you explain to me where, which? Okay, which lambda function, Linesh, are you following?
Yeah, I know. I was just guessing whether it's the parse document that the function, the
Oh,
exact
filter,
function that you're
this one.
referring to. But I'm just guessing once again.
Oh,
So
this
maybe.
one.
Oh, okay. Yes. Okay. The
Okay,
answer is yes. Yep.
okay,
This one.
yes. Uh, okay. So you have this one, what it's doing is that it's not creating the data frame, first of all. What it's doing is it's creating the label document. So what we are doing is that the data is read from the data file. I've got my data file. This is a CSV file. And the data is in a comma delimited format. I have to convert it to the format that I'm going to use to feed into the pipeline model, to feed into pipeline model. Okay. Now, what I'll do, I have a function that reads row by row, right, and converts to the format that I need, map, right? Map is going to call the parse document function that's defined on top of the notebook. What this will do, remember that lambda is sort of like a function, right? Well, what we are doing is this. S is a row in the file, and this is checking if my data row contains text patient ID. That's what it's doing. Because the row that contains the patient ID, this is a column header, right? I don't want my column headers to be analyzed as if it was the first data row, right? You have a CSV file. The first row in the file is what? Column headers. The remaining rows are the data. You don't want the header row to be part of the training set or part of the test set. See what I'm saying? Because if you do that, you will see the problem. You will see the problem. In a Titanic example, you have a name column, right? You have a column called name. In low birth weight data, there's a column called ID, right? In this data set, there's a column called patient ID. So if it sees that I have patient ID, right, which is first row, it's not going to take that row to the parser. That's what it is. This is not a data frame. That's why I misunderstood the question, because, well, maybe it may be just me, but here it is, right? But then, oh yeah, then you take it to DF. You are right. You take documents to data frame in here. You are right. Okay. Now see here, documents, and you take this to data frame. Yes. But take a look at this data frame. What are the elements, right? What are the elements? So that's the ID, right? The ID field. Those here, person info, those are all of your independent variables. And label, this is a target variable, right? This is a target. That's a structure. I'm previewing here the first 5 rows, right? That's what it's doing. I hope it makes sense. Okay, let me see the chat. I want to make sure. Did I answer your question? Yes, excellent. Yes, because see, yeah, sure. Yeah, Titanic data is the same. It's similar, but this is a bigger data set, and it's an additional example for you, right?
Yeah, just
So
like to add that, this was a
yes.
great question. I'm glad, you asked the question, because this particular function, this particular code here, and the parsing function are the key things. If you understand this section of the code and the parsing function, you got the most of it, right? It just would fly by, because this is the piece here that you need to understand. Why are you trying to put this in this format, right? Why you are trying to extract all the fields and make it like a person info field, and why you are capturing your target variable into another column here. This is what it is doing. It is taking each row of your file and dividing into 3 sections. The first section is an ID column. The second section is the real meat in there, right? The content, the data that it is going to process. And the third is what it is going to predict, right? The target variable. So it takes the middle portion, and that's what it is going to use in the following, in the future code cells, right? When you're doing your model, the model is going to make use of your person info and compare and also your label, right? Your target. That's why this particular piece of code is very important. I need to understand this.
Yes. Yes, because this is a code where most of the errors are. So that's why sometimes if you submit the ticket with an error, we ask you to show the parser function and this piece of code. Because, well, you're gonna get this code, you're gonna get this notebook, right? Then look, compare we compare it with the Titanic data, and you will see the main differences are this parser function. Well, I played, see that this hash is a comment. I played with the combinations of the input variables here. But what you will see, just compare this notebook and Titanic. The difference that you will see is this block here. I edited this block because it's a different parser function. So you want to list your columns like this, right? So that way you can see the index, right? I see that the ID is in here. I see that the index of the target is 16, right? And etc. Because what mistake some people make is that they include the target as one of the predictors as well. So then you're gonna see the results are incorrect and etc. You know, so that's why this thing here, it's an extra step, but it's a time well spent. Now, do not change the word label. Do not do that. And here, just this is a part that was edited. Another part that was edited is, of course, you see different data set. That part is understandable. Another thing that was edited is that, well, of course, I added extra visualizations. Oh, and what does this do? This is how you would check if the data has missing values. There is a way. Well, in your data, you don't have any missing, but to make sure, this is what you do. This is pandas data frame you call is null, and then you call sum. So here it will tell you how many values are missing in each column. Okay. So just keep this code, because in case you decide to use the Python later in your capstone project, right? So this is a change, but this is just extra stuff that I added. But if I scroll down to, well, this is a part where you specify the bucket, right? The dataset name is different, of course. Now, if you scroll further down, this cell over here, this will change, okay? This cell will change, but for the most part, it's almost same. Well, in here, in this example, I'm using a different split, right? And I guess you can guess why, right? If you look at the visualizations, you can see why. That this data is what? Imbalanced, right? So, and that's it. I mean, everything else is the same. Everything else is almost the same, but you have to double check, because you cannot just take the new data and plug this in, right? You cannot do that. But see this thing here, it really helps, because take a look at this. This is my target variable. Do you see this? Values are 0 and 1. What does this here tell you? So think about it. What does this here tell you? Okay? Just think about it. You don't have to answer it right now, but you need to answer it in your paper, because there is something like that in part 2 data. Okay? Now, do you see this one here? Oops. If I was going to run the data on a subset of columns, I would probably eliminate this, because do you see how it is this prevalent, this one, see, prevalent stroke distribution? Do you see most of this is here, most of the values, and very little values in one? So I would probably want to exclude this a column from predictors, right? Because in here, in this example, I have like 15 predictors, or 16, yeah. So you probably want to do a little bit of the selection. It's not the case for your assignment data because it's small, but it just for your general knowledge, let's say, because you're taking the class to learn. You're not taking class to get the ticket punched, right? So, yeah. But let's see, do we have questions? I would like to see questions, right? Questions. I'm looking at the chat, I don't see. Please, guys, post questions. Yeah, I saw somebody mentioned questions about Titanic data. What questions do you have about Titanic data? Huh? Please, please, I would like to see questions. Well, here, sort of like I'm going over, similar to what's in Titanic data, but I'm using different data as an example because you know what's gonna happen. If I give you the answers, then the IT people will have to add me to the grade book in 2 sessions, right? Because I'll be graded then. So, you know, okay. Do you have questions? Professor Razan, is there anything you would like to say about this assignment to everybody?
My comment is only, watch this video one more time at least. Post your questions as much as you can. And if you have any issue, please try to reach out to us. And please don't leave it to last minute, last day, so that you can complete all of your assignments on time.
Yeah. Because this also has a write-up part, yeah. So I hope most of you, if not all of you, are done with part 1 by now, right? I would hope. I don't know. Okay. I did not understand the output. Okay. Let's take a look at this. All right. So in this particular, okay. I look in here. What I'm doing in this case, I'm predicting the number of people who so if you look here, I'm also predicting people who are at risk, right, and who are not at risk. So what that here does is this. Let me scroll down. This is like, it's not a confusion matrix, but it just a cross tabulation. I'm showing the counts. Well, let me scroll. Oh, it's in so first, what I'm doing first is that I'm trying to calculate the prediction, right? How many people are at risk and versus how many people are not, right? I'm doing that, and then I am building this table. So for example, label 0, right? It means that you are not at risk, right? Let's see. Okay, label, if you have label 0, it means no, you're not at risk. Label 1, it means that you are at risk. So based on my results, here I have 162 people who are not at risk, were predicted as at risk, something like that. So you're looking at the actual value versus the predicted value, okay? And then you have the number of people. So here, 29 people, right, who are at risk were correctly predicted as at risk. Now in here, you have 990 people who are not at risk and they were predicted as not at risk. And 109 people who are at risk, but they were predicted as not at risk, right? So that's what basically is. It's just a cross tabulation to help you understand just you have the false positive and false negative, right? So you predicted as you are at risk, but you're not, which is the what? False positive, right? Just to give you an example of how the breakdown is, because sometimes you may see, for some reason, this model does not work well for people who are at risk, if you will, right? Something like that, because, well, it's an imbalanced target variable. So you might be saying, okay, well, and discuss what you would need to do to handle the imbalance. I believe back in, what was it, data 640, right? Lineage might have a better idea. In one of your courses, you discussed the imbalanced data sets. That's what I know. So now we're going to apply it here, okay? Now we're going to apply it in this course, right? And here it just basically you want to look at this. Remember that when you did, at least in data 630, you did something called confusion matrix, right? Where the correct prediction would line up on a diagonal from top left to bottom right, right? But here it's a little bit different. This is just a cross tabulation, that's all. Did I answer the question? Please let me know. And see, this is a cross tab. Okay, that's what it is. Yes, oh, excellent, excellent. So this is just the count, yes. Yeah, I'm so glad that we have questions, and it's a great idea to look at the different example, because, well, we don't want, yeah, well, Titanic is your assignment, right? I'll answer specific questions, but this we discuss. Usually when I discuss something, when I show an example, it's better to show a different on a different data, because you have extra example, right? So oh yeah, yes, in 640 this is predictive modeling, right? Yeah, right. So because 640 is listed as a prerequisite for 650, right? So I guess anything that was covered in 640 can be applied here. That's my understanding. Yes. Yeah. So this is your opportunity to review, right? Because you all probably did a great job in 640. That's a prerequisite to be here. So, I mean, and also one of the part 3 question on overfitting. Well, at least I'm aware that it's covered in 630. So this is also a good review, right? Yeah. So anything else? I would like to see questions and also submit tickets, because, well, weekend is the best time to submit tickets. I'll tell you that, because, well, myself, I set aside more time to help you during the weekends, because I know that most of you probably are doing the assignments on the weekends and on the evenings, which sort of goes well with TA schedules, because TA also work the full-time job, right? So most of you study in the evening, and we are there to help you, okay? And in the weekends, myself, I check emails, I check tickets every few hours. So we're gonna do our best, and we're gonna be checking this weekend too. So do not wait until the last minute, okay? Weekend is a better time to ask for help, okay? Can you show the step you took to tune parameters to improve accuracy? Well, Rachel, in this case, what I just did, I did not spend much time on it, but what I did was I changed this thing here, where I'm splitting. Instead of doing 80% training data, 20% test data, I did 70 and 30. This is what I just did. But then I just tried, just myself, I tried different combinations. But what I was telling, that if I was going to reduce the number of columns, right, what I would do is I would probably look at this here, right? I would look at this. And as I mentioned, see this? The prevalent stroke. This is a good column probably to omit because of the skewness. right? Then I also see that the columns are current smoker and number of cigarettes per day. Those two columns are not independent from each other, right? Then I could probably look at the distribution of the number of cigars per day. And I would think which column should I keep? A number of cigars per day, or if I should rather look at if the person is a smoker or not, right? So I believe I had this column somewhere here, okay? So I would look at that. There is no right or wrong approach. Oh, here it is. Take a look at this. This is the number of cigars per day. Take a look at how this distribution is skewed. So let's say for analysis, I'd probably be interested if the person is a smoker or not, right? This is what I would do. So what probably, if I was going to do column elimination perhaps, right? I would probably remove the number of cigars per day. Then my next candidate would be this one, right? Then probably if a person has diabetes, because in my sample, I don't have sufficient number of patients with diabetes. So I would look at it this way. You would eliminate the feature. Well, no, it's not lambda function. Lambda function, right? That function before we create DEF, that does not eliminate the columns. That function does not eliminate the columns. That function eliminates the row with heading. It does not delete the columns. But when I say eliminate the column, this is what I mean. Over here, do you see this where I'm constructing this text value? What is this? This is a delimited list of the predictors, right? So to eliminate the number of cigarettes per day, I would go up over here and I would check cigars per day is at position 5. Then I would go to this statement and I would delete this part of the code. I would delete just this part of the code, okay? So now remember, in here, in this parsing function, you are specifying which columns you are using as your predictors, right? You're doing it here. But the filter column, the filter function, it does not delete the columns. It does not delete the columns. What it does is it ignores the row with the headings. It ignores the row with column names, if you will. Okay, that's what it does. But the reason it says patient ID is because how do we identify the row with the headers? It's a row that has this text, right? Well, here we're making assumptions and none of the column values will have patient ID, okay? So if the cell contains the word patient ID, it means that that row should be eliminated, okay? It's eliminating the row. So I don't know if I have the data set saved in my folder, because I could show you the CSV file. The first row is column head. Oh, excellent. No. This is a very common question, Michelle. This is not just a, it's that question is dominant. So I'm so glad somebody asked. It came up in several tickets and it came up every single semester. So that means that we may need to do a better job with an explanation somewhere. So I'm so glad that you asked. It's not just you, you know. It's an excellent question, right? So, but for the tuning the parameters, Rachel, there is no right or wrong answer. But in this case, you probably look at the correlations and you want to look at the distribution because and in case in my data, I don't have that many patients with diabetes, right? It's just a few. So it does not make sense for me to look at the diabetes column. Well, etc. You probably want to look at that, right? The skewness, and then you want to look at if you see the dependency between your independent variables, right? They want to be you want to check if they're dependent from each other, right? Like here you will look at if the correlation is close to 1, perhaps, right? You don't want you want to address that. So see here also I have this diabetes and the next field, the field that goes right after, or see this? I think it's a diastolic blood pressure, something like that. Well, but we're gonna exclude the diabetes because we don't have enough patients who have diabetes, so we're probably not gonna use that field for analysis here, okay? So there is no right or wrong answer, but you need to explain your solution. That's the thing. Well, something similar to what I showed you to ungraded exercise 3. There is multiple ways to solve the problem. You need to explain the solution. Okay, no problem. I'm so glad that I addressed the question. Yeah. Did you show how you're interested in the image? Well, well, I just like this image because it's a visual, and well, I just like this because first of all, it's not only uses the colors, right? It also lists the numbers, the actual values. Okay, it also lists the actual values. See this? If you say annotate equals true, you want to list the values. Yeah. Oh, the heart image. Oh, I found it. Yes, I found this heart image. Yes. Yeah, I found the URL and I put it in a table. So how I inserted the image, let's take a look at this. Okay, excellent. Take a look at this. It's this. Because I have an HTML code for the table, right? I have an HTML code for the table. Then in the first row, see that this is a table, and a table consists of rows. So this is the first row, TR. In the first row, table data, those are the cell 1, right? Then this is a second cell, the third cell, and this is a fifth cell. And this is a source. So what this is this, it's a URL. So this is a location of the web. So if I go in here, this is a URL where this actual image is, right? The GPG. So when I go back to my notebook, it's here. But what I had to do is this. I have to make the row span equal 17 because I want that cell to span across 17 rows. Just in that example, you have to look at how many fields you've got. Okay, you have to look at how your table looks like. I kept on playing with this. But then you're gonna have another 16 rows with less cells. So in the second row, you're gonna have 1, 2, 3 cells instead of 4 because your first cell in the first row spans multiple rows, and it's just this here. Okay, image, and this is a source. It's inside this table data. I hope I answered the question. Okay, I hope I answered it. It's on HTML. Yes, try again, and also if that did not work, let us know. All right, because this is see that this, if I run this, right, this is how it looks like. So that's an HTML. You do this table, right? Table opening, table close tag. Then you've got the table row, table data. But when you mention that does not work, includes the screenshot of how it looks like. Maybe we need to adjust the row span, maybe something else. Maybe there is a tag that needs to be closed because each opening tag, table data, it must have the corresponding closing tag, right? This is the HTML, and then you specify the column width, the text alignment, etc. Right? To this markdown, it takes HTML language as well, right? So let's see. You had similar issue. Yes, yes, you need to play around. Exactly. This is what I did here. I played around. Yes, yes, yes. Oh, oh yeah, yeah, yeah. Yes, because well, this is what I did. I did some playing around with this. Yes, and you might notice that everywhere, like in Leo and course content, tables are used because you've got the images and you've got the that section where you see the objectives for the week, right? That's table because you've got the image in one column, right? So that's a cell that spans multiple rows, and a text, right? You have rows of text where you see the objectives, and that image spans several rows, right? Same thing here. Something here, same thing here, see? You have the image spanning multiple rows. Well, that's a good to know because a little bit of HTML will help you later on. Trust me, it will. Okay, it does not hurt. It may help, right? So hopefully that helps, right? Let me see the questions. Do we have questions? Oops. Chat. Okay. Questions? Is there anything that Yelena wants to add? Yelena? Do you want to add something? Olinesh?
No, I think you covered it all. So, no, great job here.
Thank you. And Yelena? I don't know if she's still here. Oh, you cannot speak. Oh, no problem, Yelena. No problem. No problem. No problem. No problem. I'm not gonna do that.
Yelena, very good session. Thank you so much.
Oh, most welcome. So what I'll do is, once we have the recording, right, I'm gonna send you guys a link, and I'm gonna send you this notebook, okay? And also the slides, and also the data set in case you want to play. But if you want to play, you're gonna need to change credential, okay? Okay, sure. Sure, most welcome, guys. All right, I'm gonna stop sharing, and Yelena, you're gonna stop the recording, right? Okay, most welcome, guys, and keep up the great work. Okay.